Okay, so we are starting chapter 8, and this chapter deals with right triangles, and it's probably my favorite chapter. It's pretty short because used to the geometric means thing we did in the last chapter was in this chapter, but this book puts it in with similar triangles, which kind of makes sense. But anyway, so I broke 8.1 up into two parts, and then we have 8.2 and 8.5. We'll probably spend 2 days on 8.2. I think I'm going to change my mind. But we do have a quiz over radicals on Wednesday. No calculator. There's only 10 questions. The numbers aren't big, so it won't be an issue not having a calculator. It shouldn't be an issue if you know what you're doing. Okay, so the first part of this lesson you should be familiar with because we've been working with the Pythagorean theorem all year. Okay, and you've done it in years past as well. But the Pythagorean theorem states that if a triangle is a right triangle, then the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. Most of you know it as a squared plus b squared equals c squared. Well, your a and your b are always your legs. Your c is always the hypotenuse. Your hypotenuse is always the longest side of the right triangle. It's across from the right angle. Okay, and remember back in chapter 5, we learned that your longest side is across from the greatest angle. Well, if you have a right angle, there can't be a bigger angle than that, okay, because there's only 180 degrees in the triangle. Some teachers teach instead of a squared plus b squared equals c squared, they teach leg squared plus leg squared equals hypotenuse squared. Basically the same thing. If you know what c is and which one's a and b, it's the exact same thing. Okay, so in this particular problem, it is a right triangle. We use the Pythagorean theorem when we know two sides of the right triangle and we're looking for the third side. Okay, so the leg is what's missing. So we're going to do x squared plus 7 squared equals 14 squared. Okay, what is 7 squared? 49. What's 14 squared? 196. How did I tell you to remember that? 13 is unlucky. 13 squared is 169, right? So 14 squared, you just transpose the last two digits. Okay? All right, so we subtract 49 from both sides, and we get, I believe it's 147. Yes, okay, 147. Okay? So we take the square root. All right? What's the number that goes into 147? 7? True. Did you just guess, or do you know that for sure? Oh, okay. Okay, well, let's say you didn't remember that. What could we check? What else goes into that? You're right. 7 does. 7 does. 3 does, right? Okay. 3 does, because 7 plus 4 plus 1 is 12, right? So 3 goes in there. 3 goes in there 49 times, right? Okay. So it can break into 49 and 3, and so Isaac was right. We end up with 7 radical 3, okay? This is what we call an exact answer, okay? If I had taken my calculator and just plugged it in, I would type it in right. I would have gotten 12.1, approximately, okay? Why is that not considered exact? You round it. Even if I put that entire thing that filled the screen up in the calculator, even if I put that in there, it's still an estimation, okay? Because rounding occurred. Okay? We want to keep things exact if we're going to do more math with them, okay? Like if we're going to use that answer in another part of a math problem, we definitely want to keep it exact. It makes the problem easier to work with, for one. If we're wanting to know how long a ladder is, we want an estimate, right? We don't want a ladder that is 7 radical 3 units long. Do we know what 7 radical 3 is? No, okay? Now, the Pythagorean theorem is very helpful in a lot of ways, and people kind of laugh at me when I use this example, but firemen can use the Pythagorean theorem to estimate, okay, if they want to figure out how big a ladder they need. But the reason I say this is because when I first started teaching, I think it was my 3rd year to teach, I was teaching in Texas, I was teaching the Pythagorean theorem, and that's when the Oklahoma City bombing happened. And I remember watching on TV, you know, the horror of it all because it was just awful. But you know, the whole side, one side of that building had collapsed, and there was rubble down here at the bottom, right, Isaac? Right, Harris? Okay. And so all these people were stuck at the top, trying to get out because they were afraid there was another bomb. I mean, it was a really scary deal. And I remember seeing people working, trying to get these people down. And I remember them taking a big ladder truck and getting as close as they could to the building and hoisting that ladder over there, and it didn't reach. They couldn't get there. So those people were like, oh my gosh, you know. But being a fireman, knowing the Pythagorean theorem would be beneficial because you could estimate how high up they are, estimate how close you can get, right? And the ground and, you know, the building are going to make a right angle, right? So you estimate how high up they are, estimate how close you can get. That's going to tell you how big a ladder that you're going to need because you could just kind of do it mentally in your head, okay? So there is uses for the Pythagorean theorem. If you're going to go into engineering, definitely you would use it quite often. Anyway, now the converse. Now this is something you might not be as familiar with. This is what we use when we want to determine if a triangle is a right triangle. And so if the numbers that make your triangle satisfy the Pythagorean theorem, then you know that it's a right triangle. Now, you always need to make sure that it's a triangle first, though. Do you remember how to determine if three numbers make a triangle? Two smaller sides have to add together to be greater than the third side, right? The longest side? Okay, so any two sides have to add to be greater than the third side, but you definitely want to check the two smaller ones and the longer one, okay? So if it makes a triangle and I can plug it into the Pythagorean theorem and it works, it's a true statement, then we know that it's a right triangle. Okay, so, for example, first of all, does this make a triangle? 30, 16 is greater than 34. Okay. So then we're going to do 16 squared plus 30 squared equals 34 squared. Okay. 16 squared was 16 squared. You should know that one. 256. 30 squared is 900. 3 times 3 is 9. Double the 0. Okay. And 34 squared. I don't know that one. 1156. You alright? Okay. So then if I add 256 plus 900, I get 1156, and that's equal to 1156. So this makes a true statement, yes? Okay, so we know that this is a right triangle. Okay? Alright, here's another one. We want to find x, y, and z. What do you notice about the relationship between the sides of the triangle? Okay, let's find x first. Okay, what would we do to find x? Would you say 12 over x equals 9 over 12? Okay, I'm going to write it like this, but you're right. 9 is to 12 as 12 is to x, right? Same thing, okay? I always do it the other way. All right, so this is a geometric mean between the two parts of the hypotenuse. Remember, you can use that when you have a big right triangle with the altitude drawn. Remember that altitude is the geometric mean between the both parts. Okay, so we cross multiply and we get 9x equals 144. Divide both sides by 9, and that goes in there 16 times. Okay, so that right there is 16. Okay, what do we use to find z? You could use it, but could we use the Pythagorean theorem? Yeah, you could either one. I'm going to go ahead and use the Pythagorean theorem. So 9 squared plus 12 squared equals z squared. 9 squared is 81. 12 squared is 144. 81 plus 144 is 225. And what's the square root of 225? Okay, 15. That's another one you need to know. Okay, what do we want to do to find y? Pythagorean theorem? Okay, so again, we've got 12 squared plus 16 squared equals y squared. So that's 144. What's 16 squared again? 256. Let's memorize that one. 144 plus 256, that is 400. What's the square root of 400? 20. Okay, so that answers for x, y, and z. Now, it says, what do you notice about the relationship between the sides of the triangle? Well, first of all, when you have a right triangle and you draw the altitude, you create three what? Three right triangles, three similar triangles, right, Isabel? Okay. And so if I look at all three of these, let's say I've got 9, 12, 15. That's the little one. The medium-sized one is 12, 16, 20. And the large one is 15, 20, 25. Okay? Now, these all are similar, right? Do you notice anything that they might have in common? These are all multiples of 5, right? Okay, so if I did 3 times 5, 4 times 5, 5 times 5, right? So 3, 4, 5, these are all multiples of 5. What if what is this one? Multiples of 4. 3 times 4, 4 times 4, 5 times 4. What about this one? 3 times 3, 4 times 3, 5 times 3. Okay? Those numbers, 3, 4, 5, is what we call a Pythagorean triple. Those numbers always make a right triangle, okay, as long as 5 is the hypotenuse, all right? And so 3, 4, 5 is one of the Pythagorean triples. So I could take and I could multiply them all by 2, 6, 8, 10 is going to be a right triangle. Multiply them all by 3, that was the 9, 12, 15. Okay? Multiply them all by 4, that was the 12, 16, 20. Those are all triples, okay? And those are important to know because if I had a right triangle, okay, and I knew that this was 3 and I knew this was 5 without doing any work, I know that that's 4, okay? But the pieces have to be in the right spot. If this was 3 and this was 5, would this be 4? No, because the longest side has to be across from the right angle, okay? All right, 5, 12, 13 is another triple. Both of these we use quite a bit, okay? The others you see, but these two you see a lot, and they're families. So, like if I multiply through here by 2, that's 10, 24, 26, or multiply through by 3, 15, 36, 39. Those are going to give me a right triangle every time. 8, 15, 17 is a set. 7, 24, 25. Another one I don't have up here. 9, 40, 41 is another one. Okay? Those will always give me right triangles. I would try to become familiar with these two in particular, the first two. Okay? You're going to see those a lot. And maybe 6, 8, 10. You know. All right. Okay, so if I were given this problem to do, what would I do? I want to find x. Okay, so 10 squared plus x squared equals 26 squared. Okay, we can do that. Anybody have another plan? That would definitely give me the answer. Is this a triple? Is it? What family? 5, 12, 13. What's the multiplier? 2, right? 5 times 2. This is going to be 12 times 2, 13 times 2. I can do this problem, and I don't have to do the Pythagorean theorem, but if I don't recognize it as a triple, is that what I should do? Yes. Absolutely. Okay? And the more you start working with these, the quicker you start recognizing it. Okay? So you might have to do the Pythagorean theorem some, and that's okay. And then you'll get halfway through it, and you're like, oh, this is one of those triples. And then you'll start to see it. Okay? All right. Damon is locked out of his house. The only open window is on the second floor, which is 12 feet above the ground. He needs to borrow a ladder from his neighbor. If he must place the ladder 5 feet from the house to avoid some bushes, what length of ladder does Damon need? Okay, so we have Damon's house, okay, and here is the bushes, and here is the ladder, okay? The window is 12 feet above the ground. The bushes are 5 feet deep. You keep the ladder from being 5 feet from the house, okay? The house and the ground, in a perfect world, are right angle, okay? So how long a ladder does he need? He needs a 13-foot ladder, okay? All right. Now, this last thing is probably something new. We may or may not have had this before. But this is called Pythagorean inequality theorems. And basically, we can use a form of the Pythagorean theorem to determine if it's an acute or an obtuse triangle. Okay? If it satisfies the Pythagorean theorem, it's right. Okay? But then we can test to see if it's acute or obtuse also. Okay, so what you do is you take the longest side and you square it, and then you compare it with the squares of the two smaller sides. So we still do the a squared, b squared, and c squared, but then we have to compare their lengths. So if the shortest side, if the longest side squared is smaller than the sum of the squares of the other two sides, it is acute. Okay, so if it's smaller, if the longest side squared is smaller than the sum of the squares of the other two, acute is small, so it's going to be an acute triangle. If the longest side squared is greater than the sum of the squares of the other two, then it's an obtuse, because if it's greater, it's bigger, it's obtuse. So you always want to start with the longest side and compare it with the other two, okay? The longest side is smaller than the other two squared, then it's acute. The longest side squared is greater than the squares of the other two, then it's obtuse, okay? So let's do a couple of examples. But again, always make sure it's a triangle to begin with, okay? So let's do that first. Does this make a triangle? Yes, 7 plus 14 is greater than 16. 20 plus 48 is greater than 52. And 8 and 15 is greater than 16. Okay, all right. So again, we start with the longest side. We square it, and then we compare it with the sum of the squares of the other sides. What's 16 squared? 256. 7 squared is 49, and 14 squared is 196. So if I add 49 and 196, that's 245. Okay, and then that longest side squared was 256. So that longest side squared is bigger than the sum of the squares of the other two sides. So what kind of triangle does that make it? Obtuse. Okay, what are we going to do here? Same thing, okay? So we're going to take that longest side, 52 squared, and we're going to look at 20 squared and 48 squared. Okay, so 52 squared is 2704. 20 squared is 400. 48 squared is 2304. What do you notice here? Huh?
They're the same.
They're the same. So what does it make it? It's what? Right triangle. Yes. You could. I was waiting for somebody to say something. Right. He said, couldn't you just see that it's a family of the 5, 12, 13? Is it?
Yes.
What's the multiplier? 4. 5 times 4, 12 times 4, 13 times 4. But like I said, you don't always recognize it, right? And so sometimes we have to work through it, okay? But that's good. I'm glad you recognize that. Okay. Here's another one. Longest side squared is 16 squared, and then we have to look at 8 squared plus 15 squared. 16 squared is 256. 8 squared is 64. 15 squared is 225. So, let's see. If we add that together, we end up with 289. Is that right? Okay. The longest side squared is less. So what does that make it? Acute. Okay, now I want to give you one more. We'll add d onto that. Radical 3, radical 4, radical 5. Okay? I want to know what kind of triangle this is. Now, I need to make sure that it makes a triangle, right? So you would need to check that in your calculator. Radical 3, make sure you close the parenthesis and square it. no, don't square it. Radical 3, close the parenthesis, plus radical 4 is about 3.7. Remember that number. Radical 5 is 2.2. So is it a triangle?
Yes.
Okay, yes, because the sum of the squares of the two smaller is, no, the sum of the two smaller is greater than the larger, so it is. All right, so now I want to see what kind of triangle it is. So I take the longest side and square it, and then I take radical 3, square it, plus radical 4, square it. What is radical 5 squared?
5.
Okay. What is radical 3 squared? What's radical 4 squared? Okay, so 5 and then 3 plus 4 is 7. What is it? It is a cube. The longest side is smaller than the other two added together. So this is a cube. Okay? All right. Once I give you your paper, there is one problem that I want to get you started on.